Hi, welcome back. So let's get started. So I guess last time we finished the discussion of the dispersion spread and the shape, right? So let's quickly review what we have done, and then we'll go into the correlation coefficient, and then we'll go to Excel. So hopefully we finish all this crazy number of slides. Excel will try to be slightly quicker than usual because I expect you know how the basic operation of Excel, but try to introduce you the functions and things. In case of problem, just to stop me. So it's more like a tutorial style. So I just go around to see if any question about Excel. Okay, we go over some of the function and then you see. Okay. So we're quickly what done. Descriptive statistics. Why we're doing that is the reason is because of this is what we call the exploratory data analysis. So usually you got the data, you collect them, clean them up, and then you want to do this kind of work to see what we call summary statistics, right? Look at the mean, median, mode, variance, standard deviation, so on and so forth, and see what kind of thing can be done further. And is there any problem of the data cleaning? And are you collecting the right data, so on and so forth, right? And then see whether strange thing happen, and then you want to take a look at those. Okay. Let's see. Did I share the right screen? Oh, I didn't. Did I? I did. Okay. Just to very briefly remind or go over the different type of measure we discussed last time, and then quickly. So mean, median, mode. I'm not going to review it again, but just very quickly. Mean will be just the average, right? And this is a middle by distance. The formula is adding all up and divided by total number of them, right? And just to remind you, only meaningful when you can take the mean, right? And one thing I didn't mention explicitly is what happens if your data has a missing, right? When you're missing, then how about the end, right? Because of we assume in this class is your data you are having is a nice one, right? But when you do survey, suppose you do for a project, right? You do a survey, you ask questions, and very likely you have missing problem, right? For example, you try to let's do a survey, asking how you would rate the canteen in Swiss K, right? Here, I think Swiss K have more than 20 canteen, and I guess none of you go to everyone, right? As most of you go to not go everyone, but you are definitely missing, right? How do you do that, right? I mean, when you're missing, are you going to assign some value or you just omit it, right? When omit it, then it's easy, right? Just divide by n. But sometimes omit may not be the right thing. And there's some issue how you do omit, right? For mean, probably okay to omit, right? But what about median? The middle guy. Okay, median is middle guy, right? When you have a missing data, how can you handle it, right? The way to handle it is a very sensitive issue, but I'm not going to go about it because we assume everything is nice here. Okay, but do keep in your mind that missing data is something that you should be worried about, right? And missing data is very often, right? Especially when you work with big data, definitely you will have some missing because you have so many variables to collect from people. Missing is natural. Okay, how do you handle those? I mean, you have to make your own judgment. It's not our class to cover, but these are the important issues that will arise when you actually work on your project. So I just want to remind you how you handle that. Okay. Mode shouldn't be an issue even if missing, right? Because the most frequent one. And last time we covered these 5 measures. Just very briefly remind you what are these, right? Range will be just the biggest minus smallest, right? Interquartile range, in notional sense, is you cut the data into 4 equal parts, right? And you take the boundary between the first 2, right? And the third and the fourth, right? The difference, right? Notionally will be just like this, right? You just cut the data into 4 different parts, right? And by the math problem, right? When you cut 4 different parts, actually you have 3 cuts, right? The middle cut is median, and the difference between these 2 is called the IQR, right? And one measure we didn't mention in our class, but sometimes you often see it, is what we call the 90% 90%, 10 percentile range. Okay, instead of say we have where's my pen? Excuse me, where's my pen? Hey, no pen. Okay, oh, it's here. So here is like sometimes you call this 75%, right? And this 25%. Okay, and sometimes you see they call 90%, 10%, 90% percentile range. Okay. It effectively mean the following: it's 90% and 10%. Look at difference. Okay, I mean the way we do 90%, 10% will be same as the way we do for 75 and 25 linear population. But this is also one of the things that you sometimes see, but same idea, right? So interquartile range is 75 to 25, but the 90 and 10% is like 90 to 10. Okay, but that is same as you truncate the top 10% and bottom 10% from data, right? You take it out from the data and then you just do the range. Okay, but anyway, I mean, I just mentioned because sometimes you see it. Okay, and the variance will be the distance from the mean, right? For average square distance from mean, right? It's just distance you square, right? And just one thing I have to remind you again is this n and n-1 idea. Okay, we always want to measure the sigma square, right? This is the thing we study because it's meaningful, right? Average square distance from mean. But when you collect data, you use the data, try to estimate, or try to guess what is the sigma square is. You use the S square. Okay, just to remind you, later we talk today is, right? This is the VAR dot P. This is the VAR dot S, right? And we will be using VAR dot S for our purpose. Okay, but do remind you that you're actually doing is looking at the sigmas in the population. Okay, suppose the population there you have a sigma square, right? But if you want you're getting some data to estimate what it is, then use the variance dot S. The reason why we use S instead of P will be clear when we talk about estimation in the topic 5. Okay. But here, just take it as given. Okay. And if you take the square root of the variance, you got the standard deviation. Okay. And I want to remind you that mean and the standard deviation or variance is the main thing we focus on this class. Basically, second half of this class is basically all the time we talk about these two measures. Okay, we don't talk about IQR, range, median, or mode after the first class. Okay, sorry, after the first section, first topic we're covering. And CV is nothing, right? But just we normalize it without the unit. The reason why we do that is I think it's useful to compare different across different data set, right? Because different data set can have different mean, and then you want to compare the spread of the two data set. That is the way you do. Okay. Lastly, we cover the skewness and kurtosis, right? And they're the measure of the shape of your data, right? And skewness have a reference point 0, right? If 0, it means they're symmetric, right? If they're not 0, if they're positive, you positively skew, otherwise negatively skew. Okay. So the formula, just to remind you, this is crazy formula. Probably you cannot remember, but just notionally is not difficult because the what they are doing is just look at the numerator. It's just very similar to the variance, right? Variance is square. Now you become third, okay? And by doing so, you allow negative and positive to have in play, right? Because square, always positive. Cubic, negative, remain negative. Positive, remain positive, right? And if you have observation very far away from the mean, right, then this value will make it very big, right? Because the mean is at the middle, right, of the data in some distance. So, but it doesn't take into account into the square or cubic, right? So, and you divide it by the standard deviation, multiplied by itself 3 times, is to make sure that the skewness is unitless, right? Doesn't affect by how big it is, right? And later we will see this is in the Excel. If this is later, this is called skew dot p, okay? And again, we usually don't use this version p, okay? We'll use the version we call this skew without dot p, okay? We'll use this guy, right? This guy looks not very friendly, okay? And don't worry, we will, I mean, unless doing assignment, but yeah, that might you may be asked to do it, but unless I have nothing to ask. I mean, you don't expect it from your test, right? So I mean, you should be, but you should be able to do it Excel, right? I mean, you should know the function for doing that, right? But other than that, I mean, I don't expect you to memorize this formula, all right? And some of you actually ask me, is open, I mean, just to remind you, it's open book, open notes, but whether open notebook or iPad, I have to figure out. Because at one point of time, I tried to do that, but some people want to cheat of using the laptop because I say Bluetooth and that's communication. So I have to figure out the way that makes sure nothing can happen, then I can allow you to. Otherwise, I'm sorry, you have to bring papers, which is not environmentally friendly, but I don't know how to handle that. I don't know how to jam the signal thing, but let me figure out. But it's open book for sure, open book, but whether you can bring your laptop or iPad in is I have to see what can be done there, because there's a cheating issue I have to figure out how to avoid. But let's see what happens. But you don't need to worry about memorizing formula. It's always you can bring your formula, whatever. Okay. So the skew, as you can see, this one is symmetric, so it's 0, right? And this look like this, right? If I positive skews like this, right? Just to remind you, this income data is what you see, right? If you ask people how much they make, it's really like this, okay? Because you have a bunch of people making a lot of money compared to the rest of people. So that is the thing, right? And you have a bunch of people that are making much less than the rest, then you'll be like this, right? And the society can be one way or the other, depends on the shape. And just to remind you why we care skewness, I think this is one important thing, is the financial market, right? And the skewness is actually would be taken into account in the asset pricing. They should and they will, because actually people will need to pay for that. And it's not surprising because people buy lottery ticket, right, and go to casinos. And it's actually surprising that finance literature don't take this into account until very lately. So until I think recent 2 to 3 years, they actually figure out that people actually pay for that, and they put in the model. And probably now the fund manager actually take this into account, right? And not surprising, right? People buy IPO, right? Pay a lot for the IPO, right? And also pay for the stock that they think that have a growth potential, right? .com bubble. Maybe you guys are young, don't know what's .com bubble, but you look at those days in the near 1999 and 2000. The stock, like whenever the name is called related to .com, then can raise like crazy. Recently the same, right? Whenever you have AI and the thing, and then the stock go insane. So same idea here. Because why? Because you expect if the AI that thing comes out and then it wins, then a lot of profit from that. It's not people are crazy, but it's just like people think that it's a lottery ticket. It's kind of okay. And that's why skewness is important, right? And kurtosis, if you just recall the ugly formula from the skewness, kurtosis is raised to the power 4, right? It's nothing deep here. And what is measuring is masking whether the tail is fat or thin, right? And I do want to remind you that this is very important because it's capturing the extreme values, right? It's asking whether things happen, right? And some of you may notice recent we have the government saying we have 100 years reign, right? Or 300 years reign, or 1,000 years reign, right? I mean, just like haven't seen, right? And they didn't cater it, right? The reason is like the kurtosis, right? If you forget about kurtosis, there is a problem, right? Whether you want to prevent that, but it's an issue, but it's like kurtosis, like something event that never happened in a regular period of time, but it did happen, right? And kurtosis have to be there, and then things will be very different, right? And I actually mentioned, right, it's like kurtosis is something that when it's big, then the tail is fat, then you have a problem. And the usual thing we learned in this class doesn't apply very well. You have to do other way to handle the problem. Okay, and how do we do it? It's outside the scope of this class. Okay, but I do want to remind you that when you actually go to work, right, using data, when you say kurtosis is high, then you should be very careful. Check more textbook, see how we handle those. Okay, it's not beyond now. But usually you don't have this problem. Okay, you have a problem if you are working for insurance company, right? If you work for financial firm, financial engineer, then you have a problem. Okay. Maybe your accounting, maybe because accounting is like you would worry about some rare event will happen, right? Usually the company is fine, right? But otherwise there's a problem, right? And what do we mean by big kurtosis here? Usually we compare the benchmark is 3. Okay. Why 3? 3 is the normal distribution. The bell shape we often see is the bell. Okay. And later we explain in the topic 4 or 5, we explain why bell curve is so common. It's what we call the central limit theorem, one of the most important theorem in statistics. It's saying that if what you observe is a result of bunch of random variable, bunch of random thing add up together, then it would look like a bell. The ideas look like the IQ, right? It's a bunch of events that add up together, right? Depend on how much you eat, depend on your parents or great-grandparents, what you learn, and so on and so forth, right? Depending on your IQ and the height, and also, right? It's like depend on, say, how tall and how fat you are. Many of time it depends on how your chromosome and DNA map together, and there's so many mapping between your chromosomes, right? And there's some slightly randomization over here and there, and that things become normal with the bell curve. Okay, so the bell curve is so common observed. So that's why we often compare ourselves between bell curve. If more than 3, then you could jump. Okay, so that's why we focus on excess kurtosis. We just minus 3, because this is the measure that we use. And I probably mentioned as well is the version that we actually use to measure excess kurtosis is this complete monster. Okay, I don't expect you to understand anything because it's the formula here, but this is the formula that use Excel. You can see later. It's all curved. Okay, we'll talk about this later today. This the formula is going to fit the Excel. Okay, and because when you try to use the Excel, the curve doesn't fit the formula you have, but this is the formula that Excel is using. Okay, and probably again you ask why we do this formula, same as standard deviation. Okay, or variance. The way you try to estimate the excess kurtosis is best by this one. Okay, and of course you can easily see that when n is big enough, the same thing, right? You can do a limit. I mean, if you know calculus, you should do a limit. When n is big enough, the same thing. Okay, because this guy 10 to 1 and this guy 10 to 1. Same thing. Okay, so but anyway. That's fine. So far, this is a review what we have done. Okay, is there any question? Okay, is there a question? So what we have done is we have a one particular variable, right? And then we look at this, right? Suppose X is age, income, willingness to spend, okay, IQ or whatever. Rainfall is one thing. Okay. Now we just slightly, I mean, for the moment, we talk about not a single measure, but a paired measure. right? Suppose you observe two things for a single observation. For example, we observe how much money one guy make after they graduate, suppose a fresh grad from CHK, B school, and what's the GPA he or she from the school, right? Then the question probably you want to ask is, the GPA going to affect his earning or not? Okay, that is very fair, right? I mean, if it doesn't affect, then probably don't just study at all, right? If GPA has no point, right? Probably you can study, but you don't study for exam, right? Just study whatever you like, I mean, right? So the question is there any association between them? Okay. And the way we do is what we call covariance and correlation coefficient. Okay. And if you consider finance, that's very useful, right? Because you consider portfolio management, right? You are not considering investing in a single stock, right? Suppose you consider bond and stock, say, for example, right? And what is the best combination of the bond and stock, right? It rely on mean of bond and stock, variance and bond and stock, and covariance, right? The reason is being that, how they jointly vary matters, right? The reason being that if they move together the same direction, right, then actually the stock is, this investment is less desirable, right? If one move up and one move down, right, then this combination is better because they take less risk. Okay, assume people are risk averse, you don't like taking too much risk, right? And that is the reason why in finance I talk about they're looking for investment that is not so correlated, right? They call the alternative investment, right? That's why people want to invest in safe assets, right? They want to invest in cryptocurrency, right? This is the reason why is because of the cryptocurrency is independent of what happened in the real world, right? Why people want to buy antique, when people want to buy Rolex, why people want to do the antique, those kind of stuff. It's because of they're independent, much more or less independent of what happened in the world, right? Or you want to diversify. That's why people call diversification. Diversification is like try to make the covariance less, right? It's not a finance class, so that's why I'm not going to detail on that. But that is the idea why people care about covariance, right? And at the very end of this class, we talk about regression. The regression will be understand this in more detail. Okay, we'll be a model for that. But in this class, we will just try to study how they're related. Okay, just because we are doing preliminary analysis, right? If they're related in somehow, then we do regression. Okay, and for this class of 2011, right, is the basic step. If you happen, want to torture yourself with statistics again, is 2021, which will cover regression of this kind of stuff in great detail. Okay, now we just focus on very simple thing. Okay, now the covariance by definition, you will not be surprised, would be similar to variance, right? Variance would be like the following. If you look at variance, it's like you would forget about this guy, right? Take a square, right? This is a variance, right? This is a form of variance. Now we don't multiply by itself, but multiply by y. Okay, and that's a formula of covariance. I'll explain why this is the right formula, but I hope you understand what the formula is. Okay, but what is it? Why is it? Okay, let's look at what we call the scatter plot. Will be the best thing to visualize it and understand what's going on. Okay, this is what we call scatter plot. Okay, remember each observation we have two numbers. Okay, we name it x and y. Okay, and say for this observation, okay, suppose this number is 3 and this number is 4, for example, right? This dot means I have an observation 3 and 4, right? And this observation may be 4 and 4 and 4 and 3.5, and 3, right? So there's 3 and 4, 3 and 3, right? And this may be 5 and 5, so on and so forth. Okay, so this is scatter plot. It means that if you have every observation of 2 numbers, okay, and you can represent all your data in a scatter plot. Okay, you can easily do that in Excel. Okay, later time we'll show it, but this is the diagram we have. Okay, and why we are looking at the formula is called the covariance formula. In case you don't recall, the formula is like this, right? X minus X bar and Y minus Y bar and divided by N. This is the formula. Okay, what is this formula measuring? Okay, now we call what we talking about the variance. Variance talking about the distance from the mean, right? So what we're talking about is, look at X. How is distance from the mean? Okay, which actually look at this number, looking at this distance. Okay, and the vertical line is the mean of X. Okay, remember what's mean of X? Mean of X is looking at the vertical line, move until everything from the left and the right the same. Okay, just to make sure you understand what's going on is, look at this distance. The green distance is the X, right? And you also look at the purple distance. Okay, the vertical line is drawn in the way that the purple distance, sum of them, is same as the same sum of distance on the green. Do you remember that? This is what we call the mean, right? The distance of X. Okay, so we're looking at the distance. Okay, is from the mean. Okay, is if positive means it's above the mean, right? And look at the other way around. Look at this guy, the second guy, right? Y. Again, we're asking whether this is above the mean as well. If positive is above the mean, right? The orange, right? Again, it's looking at orange color and the black color, right? It's in the middle. That's the Y bar there, right? And this expression is positive if X and Y are both above the mean, or they're both below the mean. Okay, that means this is what the graph is drawing, right? Suppose the data, you draw what's X bar and Y bar, right? The mean of X and mean of Y. If they belong to the northeast region and the southwest region, they will be positive, right? If they're on the other two regions, they're negative, right? So you add them all up, divided by N will be on average. Is it more likely to be in this two regions or the other two regions? If in this two regions, they are positively related, right? If otherwise negative. If 0, then be more flat. Do you get that point? Let me repeat because I think that's super important. Okay. So sorry for the zoom, maybe see this is clear, right? So here we have look at this data point. These are on the right hand side of the X bar. So this guy is positive. And these are on the upper side of the Y bar. It's also positive, 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 positive. And here on the left hand side, on the bottom, on the below of the Y bar, right? So these two are negative. So this thing, right? If you're on this side, one of them negative, right? So that's negative. Okay. So you add them all, observe it up, right? If the covariance is positive, then it means that more likely to be they're positive related, right? So negative like this. Okay, this is the graphic. I hope it's clear. Negative like this, right? So that's what I meant, right? If they're positive, they move together, they always go up together or go down together. When one below mean, the other one is below mean. When other one is above mean, the other one is more likely above mean. Okay, that is called the covariance measure. Okay, so just measuring how strongly they move together, above the mean or below mean. Okay, and again, just want to emphasize, if you do estimation, you do N-1. Okay. And later you will see the same with the Excel function, the same thing. You have the P dot P and dot S. Okay. Always use this counterpart sample version when you do your data analysis. Okay. Remember, we use this to measure that guy. Okay. I think I forgot to mention the analog that is a good analog. I think it's like you play basketball. I don't know how your coach taught you. There's basketball, right? There's a basketball thing, right? This is the basketball net here. Okay. So I don't know how your teacher teach you, but my teacher teach me. I'm not a good basketball player, but anyway, my teacher taught me is if you try to aim for the center of the ring, usually doesn't work unless you are super good. Okay, so what we're going to do is what? Aiming for rebound, right? Either you aim for this guy, right? You aim here, you bounce it back, or aim here, you bounce it back, or aim and bounce it back. Okay, same idea here, right? You try to shoot directly, doesn't work. If you go indirectly, okay. Another analog I used, in the other section, probably if you watch the video, would be something like, suppose I saw a very beautiful lady, okay? Then I want to ask her phone number, suppose, okay? It doesn't work, I got married, so it's a hypothetical, okay? However, I didn't suppose go there with time, I didn't got married, okay? And I met a beautiful girl, okay? I want to get her phone number, okay? What should I do? I go there, your phone number, please. Okay, would that work? No, right? I'll go to jail, right? Doesn't work, right? So what you're going to do, right? Either you should, say, send her some flower, right? Send her some gifts, whatever thing, right? Try to impress her before you ask, right? Try to talk to her like normal guy, right? Not a weirdo, right? You cannot just go directly, right? So that is the same thing happen, right? And what? When, in the Western world, but probably not here, it's like when engagement, right? You must make a big thing, right? You go to the America, look at the Twitter, or they make a big thing, right? And then you make the big thing, right? You just then go, oh, here's the ring, marry. No, doesn't work, right? You have to make a big fest, make a big party, make a big surprise, make it work. Same idea. Okay. Now, this is the last thing we talk about today about the measurement. The last measurement is called the correlation coefficient. Probably you have seen so much measurement, you will not be surprised by this is because the numerator is just covariance. The denominator will be just the standard deviation of X and Y. So let me repeat what we're doing. It's a covariance. I divided them by the standard deviation. Okay, you probably ask first why I do that. Okay, first is you divide that, then suppose X is in cm, Y is in, I don't know, money, then the numerator will be in cm and dollar, right? If you divide the standard deviation, then it's uniqueness. Okay, then it means regardless of how you measure X and Y, doesn't really matter. Second thing, and more importantly, this measure must be between -1 and 1. Okay, the proof I'm not proving. It involves what we call Cauchy-Schwarz inequality, which is not some math, but it's always -1 and 1. Okay, and the good thing is when it's 1, it means it's everything perfectly on the line. Did I have a graph here? This is 1. It's perfectly on a vertical upward sloping line. This is positive, look like this, not perfectly on the line, right? And 0 means like, it's like the best line you can, you can imagine it's like nothing, right? Telling X cannot tell you Y, right? If no matter which X you are thinking about, it's likely to be negative or positive, right? And negative look like this, right? And -1 look like exactly on the line, okay? So it's a good measure, right? You can tell you big and small, right? And I didn't write it here, but usually what people call this is strong, they're strongly correlated if more than 0.6. Okay, of course 0.8, 0.9 will be very strong, but if below 0.6, usually you would not bother to mention it. Okay, if just 0.3, 0.4, then probably just forget about it, right? You don't want to bother. Okay, if 0.6, 0.7, then you want to mention it, right? Suppose you do, remember what we do, right? Look at the GPA and your income. If, I don't know, you do a survey, figure out that it's 0.4, then you can just go home. Okay. Maybe not go home, but stay, but probably don't need to study that hard for the exam, right? You can study more for other things, right? But if it is like 0.8, 0.9, then probably should study harder, way hard, right? If negative, then probably you should never study, right? You should play more, right? But that's the idea. Okay. So this is the thing that we will return at the very end of the semester when we do regression. When we say, I almost said it, it's like we can draw a line here, right? Is at the very end of this semester, we'll tell you how to draw a line to represent this model. Okay. Why the big deal and why you would spend a whole semester if you do advanced class to learn how to draw a line is because what you're going to do is to reduce the data into a model. And the model is simple. You can do many things. You can do estimation, you can do a lot of stuff. Right? And how to build up the model, right? Even the Hong Kong Observatory, right? The supercomputer, they're actually building different model. And a lot of machine learning or AI basically trying to draw a line. Okay, of course, different line, different type of line, and then different very complication. But at the end of the day, they actually no different from drawing a line from this kind of stuff. Of course, how to draw a line properly and how to do these things is a lot of details. But at the end of the day, this is what data analysis is about, right? Try to have a more data. Right, data is very complicated. You try to condense the pattern you found from the data, try to condense into a single model, right, or multiple model, depends. I mean, make your knowledge can be summarized by a model, and then you can use for prediction estimation and various kinds of usage. Okay. And of course, why you want to do a model, right? You spend time because you do analysis, and so okay, they are related in some sense. Otherwise, if you figure out that, hey, your income is independent of your GPA, then why you want to be a model, right? We just forget about it. Okay, so that's why you want to do that, but that will be left for the next part. Any question before? No. So, some of you may ask this question: is we have talked about so many sample version. Do this coefficient and sample version? No. Okay. The reason is the proof is here, but the thing is the sample one is exactly same as the population one. Okay. So some reason because if you change the denominator and denominator by n-1, they cancel out. So turn out to be the same. So later you will see when do Excel, the CORREL, correlation coefficient, there's no P or S, so the same. So this is a very funny thing. I mean, probably the only thing in the stat is this one is always there's no sample version. Sample is the same. Maybe the mean, right? Sample mean also the same. Sample mean is the sample version, and the population is the same thing. Okay. Is there a question? Because I guess that's the end of the theory part for the topic one. Of course, we cover Excel very soon, but for the moment, is there any question before we proceed? Okay. If no, then we just go to this example quickly, and then with a break, and then come back for Excel. Okay. So quickly, this is the data. We have this data. X is 1, 2, 3, 4, 5. Y is 4, 6, 4, 7, 6, 4, 9. Okay. And that's how calculate these covariance. What you do is you take every observation of X minus the mean of X, right? And go on every observation of Y minus mean of Y, mean of Y is 6. Okay. And you multiply them together, you get this column, right? You multiply this, you get this column. Is that clear how you get the fourth column, right? And the last two columns will be very simple, right? We just square of this column with this guy, right? And you get square of this column, you get the other one. Always clear how you get this one. Okay. If you have time, you go over Excel, we actually show you how to do it quickly. Okay. And then you can also do the summation, right? Summing all this become 7. Summing all this become 10. Summing all this become 18. Okay. Because of this, you can calculate the variance of X in the population version, sample version of that, and same for Y. Also, this will be Y, sorry, typo. Oh, I don't get it. For so many years, I've got a typo. Not too many years, but 2 to 3 years, but that's still a typo. So here we can calculate covariance, right? Covariance what? It's just this guy over how many of them, right? The sum of this guy divided by n, right? The sample version is divided n minus 1, this guy, right? And the correlation, okay, will be the covariance over product of the variance. Take a square root, right? So 2 is here, right? 3.6 is here, okay? And it doesn't matter you use the sample version or the population version, right? Same thing. Or it's not the one that divided by n, right? The sum of x over sum of that, sum of that. Same. Okay. And don't worry about the calculation. You will only do it, probably do it for your assignment, right? Exam probably I will not ask you to, do this. Otherwise, it's like not doing the purpose because everyone how to calculate that, right? And you never use it in the practice, so I'm not going to test you on the test, right? Unless I got nothing to ask, but we're likely to ask that, right? Because is that okay? Okay, so as I said, that's a break of 15 minutes, and we'll come back for the exam. Okay, so we will be there were 60 pages of slide, but I think this will be fine because we are just going to there. Okay, I think I mentioned why we care about in finance, why we care about the variables. Okay, so we'll be talking Excel after the break. Okay, in the meantime, I just go around to see if there's any question. Okay, 15 minutes break. So the investment, like why do they want to do it? Let us get back to the Excel. So just mention that this is a video that I created, I mean, 2 years ago during the COVID time. They are just trying to talk about particular slides, probably old version, but talk about things parts by part. But of course, all our lecture already record already, so you can, if you want to look at what we have talked in the class, so you can just watch the video. That I put it later, but this is the video that is I record separately for a particular topic, so you can pick it up. But anyway, if you, I mean, of course, the easiest thing is you ask our TA, right? You answer directly, right? Anyway, Excel, okay? So make sure that you Excel with you. So we will go it together. Let me open Excel. I hope Excel is here. If not, then I'm doomed. But luckily, it's Excel here. So this is a window version. Okay. We are going to open a blank workbook. Okay. So this is the working space for the Excel. If you ever work on that, that will be very familiar. Okay. So I do recall that, I mean, the thing that I do Excel mainly is coming from I do an internship as an actuarial student in some local insurance company. Then basically my whole summer and the work is basically fighting with Excels. Okay, so that's how I learn Excel, because I keep working and I noticed that the people there, they actually they do Excel very fast. I mean, a lot of shortcut and done. Okay, but of course, I'm not sure they still do that, because now, I mean, that was like 20 years ago, but now I guess most of people are doing some specialized program. Excel probably might not be as important as they are, but still, I mean, if you're not, unless you are doing quantitative finance or financial engineer, Excel you will be still the main thing. And as I mentioned, right, Microsoft is putting Python in Excel, so I'm pretty sure 1 year or 2 years later, then Excel will be the super big thing, because you will do it in combination with Python. I mean, that would be the thing that in the future. So I mean, so I think it's good to do Excel. So this Excel will be very quickly, just, I mean, in case you haven't seen it, it's just a spreadsheet, a bunch of cells. There's data table, right? Is the this is the row, right? It's a horizontal one. The vertical is by column. Column is by A, B, C, D, and row is by 1, 2, 3, 4. Okay, and let me make it bigger. Here, usually I do the zooming, make it bigger. Okay, and let me follow the structure that we cover in the slide. First, I just use calculator to familiarize with the thing. Okay, so let me quickly go over the here. Okay, what I'm going to do, I just type it here in case you have any question that ask me. Okay, so in order to do calculation, Excel you would do is just put an equal sign and do standard what you do in the calculator, right? So it's 1.1, 1 plus 1 is 2. So in order to show you this, I'll use a function which we define later. We call formula test. Okay, formula test. This is trying to show you what I have typed in. I have bracket A1, which refer to the cell that I'm doing. Okay, A1. Okay, formula test A1. So you don't have to type this, because this I'm just showing you what I have typed over there. Okay, and you can easily see I can equal like 3 minus 2. Okay, so on and so forth. Right, we give you this number. If I have 3 times 5, this is the star will be the multiplication, and if I have the slash will be division. Okay, and the last one we're going to talk about is the raised to the power. Okay, 2 to the power 3 to the power is a very strange triangle shape kind of stuff. Okay, so these are the, I guess these are the 5 operations that we want to introduce to you. Is there any question? I mean, it's beginning, so I want to go over class to see if everyone got it. If you're busy with doing other things, it's fine, but if there's any question, ask me. Even if you use the Excel or use Google Sheet, it works. And yeah, Excel or Google Sheet or the iPad, it works. Okay. And make sure you know what you're doing. Is that okay? Although things are very elementary, but I try to do it. You don't need to you can forget about column 2, column B. That's no column A. Can you get that? If you have any question, just ask me, because I think this class is more like tutorial style. Because I want to make sure everyone knows Excel. Yes. okay. I mean, I hope you're able to use the differential multiplication, these things. Is there any question? No. Well, quickly, then we go to the next one. Okay, this is the thing. Okay, the next one we are going to. I mean, this is what we have. Okay, and here are two basic functions: square root, exponential. I do it. It's because I want to show you how you would do Excel. Okay, Excel is basically it's a bunch of functions. Okay, function means that it's a mathematical. You put some input, it gives you output. It's a black box, a machine. I do some process. SQRT is square root. Okay, EXP is exponential. Okay, exponential is the e to the power. Later we'll use for the upcoming thing. Okay, so let me do that here. Okay, SQRT to the 9 should give you 3. Okay, and this EXP to the 3, okay, should give you 20. So I hope you're able to enter the function. And in Excel, function will be all use the capital letter. Okay, that is the approach that adopted, I think, since the 15th version of Excel. So that will be let me know if you got it. Because SQL is square root 9 is 3. So I hope that's okay. If any issue, let me know, but I hope you can find out right. Okay, you expert Excel, you can just you can go home now. Well, cover the very basic Excel. Okay. Yeah, okay. If you use Google Sheet, should also work. There's no problem for this basic function. Okay, you're unable to work, make your Macintosh or iPad work. Use Google Sheets should also work. If it doesn't work for you, then you can use Office 365. That will also work. On Office 360. Okay. Is there any question? Okay. Because it's so easy, then I just quickly go because otherwise we don't have enough time. Okay. So now we start with statistics. Okay. So for statistics, how we do it is the basic number. First called count, and it's a sum. Okay, count is count how many elements are there. Sum is sum of them. Okay. So here I have 5 elements, then it's 5, right? Sum will be sum of them. So let me do it here. Okay. Sum. Okay. In Excel, in order to enter observations, you have to use the curly bracket. Okay, that's how Excel is being set. Maybe I use count first, right? I do count. Okay. I try to do something different from the. Okay, I have 6 here. Okay, so this is the count. Okay, and I do have sum as well. 1, 2, 3, 4, 5, 6. Okay, I do slightly different from your. So this gives you the count and sum, right? So by definition, by this, you should see how you can do the mean, right? By dividing one over the other. But if you want, I mean, that is the way you do, although I think it's not very, later you will see this is not very good way to do it, but okay, we can do this. 1, 2, 3, 4, 5, 6. Okay. So what do we have here? What do we have in the A10? Is actually average, right? Is that clear what we do? Okay. So we start from scratch. How we are doing the average? Of course, yes. Yes. The curly one, yeah. But the curly bracket comes from if you use Windows, it will be next to the P. But if you use Mac, then next to the P, yeah, you get P and that guy. So okay, curly one means this is the data. It's necessary for many purposes. Okay. Yes. If you don't, for some reason it still work, but it doesn't work in the way so it's allowed to do it, but it shouldn't work in that way. I mean, for the sum, it should be fine, but for some of the more advanced, then it doesn't work. Especially say when you do a correlation coefficient, then you don't know which ones you have to do. So that's why we the solve Excel is convenient, you can do it. Okay, but it's not something that it's a formally be like this way. Okay. Now here I have a run down and run up. Okay, but I don't want to spend time on that. But just basically, I'm not going to do in Excel. But here just means that run down means that run down 0 is the floor function, right? Run up means ceiling function. Run up, you have the decimum is 0. But I'm not going to do that. Now, here we're trying to talk about the average. Okay, just the mean. Right? So I just go over the mean. I'm not going to go about geometric. Oh, I think this is a typo. This is geometric mean, this is harmonic mean. Sorry, the typo here. Okay. I don't know why typo so obvious, but average is 1, 2, 3, 4, 5, 6. Okay. This is average. So you get the same thing here, right? So that is the good thing about Excel is most of the functions that we use for class already programmed in Excel. So you can just need to know what are they, right? Average is just the mean. Okay. Unfortunately, mean is not mean. I think R means the mean, but in Excel, there's no thing called mean. Is that okay? Average. Is that clear what we're doing? I'm not going to go about geometric mean and harmonic mean, but I want to refer to median, right? Because we learned mean, median, right? So let's do median. 1, 2, 3, 4, 5, 6. Okay. Median gives you 3.5 as you expect, right? Because median is just in between the mean of the two. Right. So that is how these functions are being used. Okay. So I'm trying to be quick here, but in case you have any question, feel free to stop me. Okay. Now, so far you can see we have been typing out the number in here. Okay. The main drawback is the data and the formula combined together. Right? Doesn't look good. So we want to separate our data and our functions. Okay. So what you'll be doing will be like this, like the following. So what usually you would do is I open another, I use the plus mark here, open another sheet. Okay. So what usually you will be doing is instead of putting the numbers there, you separate. Okay. You do say I will do 1, 2, 3. Maybe I usually call data 1, 2, 3, 4, 5, 6. Okay, and whether you do it horizontally or is fine. Okay, now I do vertically because the way I present. Okay, vertically. So column A is for data. The data here, the entry observation. Okay, so how are we going to handle this? Look nice. Okay. So remember what I make it center, okay, make it look nicer. So usually we do is like we have mean, right, and median, okay. and then I put the number here. Okay. Then I want to take average of these strengths, right? How we're going to do that is called self-referencing. Okay, the idea is I call average. Okay, AURG average, and then I use my mouse, okay, to click and drag. Okay, if you are a mouse person, otherwise you can type from A2 colon to A7. Just A2 A7. Okay, either use the mouse to click or type. Okay, here the first one I use the mouse to click and drag and release. They will give me this. Of course, you can use other way around. So you close the bracket, then you're done. Okay. I mean, I use the formula test to show this the case. This is how I do it. Or I can do the median thing. Median A2 to A7. Now you can see I just type it out. It'll work. Okay. So this is how I do that. Okay. Is that clear? One of the reasons why you want to do self-referencing is if I change the data input, the output change immediately. For example, suppose I figure out that's a data error here. I put a 7 here instead. Then you can see the mean changes, the median is not. So up to now, I go around to see the question because this is a very, very basic thing, and then what we are going to do for the rest, we just introduce you different types of function that do whatever we want, right? We learn mean, median, I can mole, and all the things of this. Okay. So, but before we go ahead, let's go around to see if you have any question you can follow or you can't follow, and then the proposal to see. But this is the basic, so you very of course easy doesn't mean that you may be stuck somewhere. So I'm open to go around. The question is nothing to do. Or what happened? Natural is a E is an exponential is a 2.7. To raise the power. We will learn this later. So that's why we call it. Is that okay? So I hope you know, I mean, how Excel is being done is that you put the data somewhere here and put what you're going to calculate on the other one. Okay? Is that okay? So very quickly, I want to talk mode. Okay, this is mode here. Mode here is very complicated for Excel to handle. Okay, if there's only single mode, then he's able to handle it. But if there's more than that, there is some problem. Okay? So let's focus on the case we only have single mode. It's called mode.single. Okay. So actually, in this case, let's do the mode. Okay. Let's do mode.single, and we try to do that. Okay. As you would expect, because there's nothing up here twice. There's because NA, right? But remember, it's the mode single. Don't put anything. Okay. So if I change it to like this, 7, then you see the actually that thing. Okay. And this function only able to capture only single mode. Okay. And that's why for mode probably you shouldn't use this function. But I just put there because we have that. Okay. If you learn use R and Python, we have to. But let's keep it there. Let's introduce you how to do it. If you actually let's call mode.multi, then you can capture multi, but it requires some more advanced what we call matrix function. So I don't want to touch those. Okay. But let's keep it there. We're able to find mean, median, mode. Okay. Is there any question? Now I want to show what we learned: range, right? Interquartile range, standard deviation, those kind of stuff. Right? So let's start with range. I guess this is how I do for my slide, right? Yeah, I do the same for the slide. So let's do range. How we do range? Range comes from what? Maximum minus minimum, right? So let's find maximum minimum. And luckily, Excel has a function called maximum minimum. Okay. So before we do the range, let's do the following. What's max? What's mean? Okay. Max, very simple, just max, as we expect, max of this data. Okay. Mean will be just mean of this data. Okay. Then range reward will be just max minus mean. Okay. So this is usually how I do Excel is not to put everything in the same. Okay. So maybe I just do one thing. So I can do this max minus mean. I can do that. That's one way to do it. Why I can do that. Okay. And for simple function, you can do this. You can put everything in the same line, right? But usually what I do is instead of doing that, I would just say do the max minus mean. Okay. Then I will do it, right? I just take things into 2 steps. I calculate this, and I do the subtraction. In this way, I make my calculation more transparent. Try to break down the problem as small as possible. And then when you try to understand in the future, you know what you're doing. So usually I recommend doing that because you would know very well when you do it. After 10 days, you do it. Okay. So that is my experience. You try to break down. So if you think easy, then you can do the D7, otherwise the D number 8. Is that clear? That is how you do the range. Okay. And how you do the quantile. Okay. The quantile is Q1 and Q4 or IQR to IQR. The IQR, the way you learn in the class, is called quantile exclude. Okay. EXC exclude. It means that that's what we call quantile include. Okay, but the way we learn is quantile exclude. Okay. Include some other way to compare. Okay. Quantile exclude the way we learn, and this explain what we get in the class. If you go back to check the example, this okay. Quantile exclude and quantile. 1 is the Q1, 3 is Q3. Okay. So that is how you do if I want to do IQR, right? Is I have a Q1 and Q3, right? So the IQR Q1 will be quantile exclude, okay? And then I have from A2 to A7, okay? And then Q1 is just 1, okay? And then I again have quantile exclude, and A2 to A7 is my data, and 3. Okay. This is what I have. Okay. And IQR will just different. Let me do it and then go around to see if you have any question related to that IQR. Okay. It's just Q3 minus Q1. It is Q3 minus Q1. Okay. So as I said, do we have IQR directly? I think we have, right? Do we have? Oh, no. So there's a function. So if you want to calculate IQR of Excel, this is how. Okay. Is that clear? I hope that's clear. How you're able to do quantile and IQR quickly. That's why I said don't worry about calculations, right? It's already there in Excel for you. And that's why we learn those formulas in the class, because it's exactly the same. And exactly. Is that okay? Now I just continue to do is I would do the variance. Okay. I will do the variance. Okay. Variance, there are two versions. Variance.P and variance.X. Right? Remember, P is divided by N, S is divided by N minus 1. Okay. So it's very simple, real quickly. Variance, we just variance.P and A2 to A7. Right? And I just type it out. If the population version will be variance.S, A2 to A7. Okay, depend on data, but okay, this is how you do variance. Okay, quickly. So you never have to handle those kind of things, but this is the problem. Quickly. You make a little bit properly. I don't go over everything in the Excel slide. I just pick the most important stuff. Hope you know how to do the variance. Just stop here before we continue. Is that okay? So now with your data, you have different data, you know how to calculate mean, median, probably mode, and range, number range, variance, SD. Now I teach the SD. SD will be simple. SD, SD, P and SD, S. There are two ways to do it. You can take a square root of the variance, right? You can do SQRT, but since with the formula, we don't have to do it, right? We can just do STD EV dot P A2 up to A7. Okay. And then we can do STD EV dot S A2 up to A7. Okay. You can take a square root of this guy. That's clear what it gives you the thing that you got. Then practical variation. That would be something that you would be probably asked to do with assignment, right? How to find this formula. So okay, I think we'll go with the same formula. Is that okay? So we should be able to calculate coefficient of variation, right? Divide that by the average. I'm going to do it. You should be able to do that. Okay. So what is left is covariance, right? And coefficient of correlation, right? So is there any question before we go? Is there a question? Everyone, I hope able to do that. So now I want to do sorry, I forgot the kurtosis and skewness, right? So for skewness, we said we have skewness dot P and skewness, normal skewness. Okay. Got the same thing, skew dot P, A2 up to A7. Okay. So this data is possibly skewed. Okay. And if you do the sample version, you're same. Okay. So actually this is more skewed, right? Pretty skewed. And for kurtosis, you just cut, right? The sample kurtosis. Remember this kurtosis is sample version. So this is excess kurtosis. Remember, you compare this to whether bigger than 0 or less than 0. Okay. No need to -3. So for kurtosis negative, remember what does that mean? That means that it's not a fat tail, it's thin. So you don't need to worry too much. Exactly. This is we've done all the calculations. You should be able, if you're given data, you should be able to say how you can calculate all these things. Okay. Of course, the Excel things are very easy, right? But do remind you that this A2 plus A7 because of data. Okay. If you are longer, they change. Okay. This one is you have to change. Okay. This thing is the same, but this adjust according to data. Right? Where you put data. Okay. Then a question. Lastly, we want to go over how you can handle the covariance and correlation coefficient. Is that okay? I mean, I will send this Excel file on the platform. Okay. Maybe I just say first, otherwise things, I don't know, someone will delete that thing. So I put 14th of September 2023. I put that there later. Okay, I'll put the blackboard later. Okay. So number 3 here is the spreadsheet number 3 of another one. What I do is I have 2 variables x and y, right? Imagine x and y would be just like you have your GPA and your income, right? Okay. Maybe x is your GPA, right? Maybe 3.5, 3.6, 3.8, 3.7, 2.5, 2.6. Okay. And then y is the income of the first monthly income of the first job, right? Maybe like oh, it's too little, right? I should be more add some more money to there. Maybe this guy is go to investment bank. I don't know, investment bank will be more, right? Make you more happier. Okay, there's a number. And this guy maybe go to I don't know, whatever. Go to be consulting firm. Okay. And this guy, I don't know, go to accounting. I don't know. This much. Oh no, more, right? Sorry. And then this guy maybe go to, I don't know, become a teacher. And this guy, I don't know. Okay. Whatever. Okay. So now this is data. Okay. So what we want is we want 2 things: covariance and co-distribution coefficient. Okay. Covariance have two parts, right? We have covariance P and covariance S, and correlation coefficient. Okay, the three things. Okay. So let's input one by one. Say covariance is covariance dot P. Very simple. Covariance dot P. And here we have to input two arrays. So we have to input first column and the second column. Okay. So what we're going to do is we'll highlight A2 to A7 first, and then comma, and then Y. Okay, so that's the only difficulty is because there are two series of number. Okay. So here is the first guy is P.5 and expecting 25K. Okay, so that would be the covariance. Okay. So this is how I do the covariance. P, you can imagine the covariance S will be divided by n-1. So this is that's the thing. Okay. So this number is much larger. Okay. So here actually means that from this data, you can say people who graduate with higher GPA actually have earned more. Okay. That means that if you believe this data, which are made up, and you should study, right? Okay. Lastly, this number is big, but doesn't tell us how strong they are. So we want to normalize it from -1 to 1. So that's why we look at correlation coefficient is CORREL. We do the same, two column there, comma the other column. Okay. So if look at this one, the coefficient is like less than 0.4, actually less than 0.6 as well, right? That means that it's not very strong. So it try to say, okay, probably it doesn't be that bad. Okay? So that's the reason why we're putting it. Okay. So for Excel, we end here. There's a time. So I just go around to see if any question. We still have several minutes, but if you're done, you can go. Because I'm pretty sure some of you have questions. So if you're done, you can go. Okay? Because sometimes I just overrun the time. So today I did 3 minutes earlier. So if tomorrow I have 3 minutes more, then you don't bring me. Okay? Just go home 3 minutes earlier. So I have enjoy the weekend. I'll see you next Monday. I'm still here. I'm staying here until you're okay. Any question? If okay, then you feel free to leave because some of you have to catch a bus because it's far away from the main campus in case you want to go. I'll be around to answer the question I have. Only do one by one. A1, A2, A7, and comma. That's more common there. Because this is the X is the Y. Or Y is it doesn't really matter, it all doesn't matter for the moment. Same thing. But you have to put a comma over there. Good. Ask any question if you have any. Although it's very simple, you should know it. This is what you do for your assignment, which I will release after we do the topic 2. There's no assignment for the big one, so we'll do it together with topic 2. Because it's too simple. If I do assignment, then just do it within 10 minutes, you're done. So make it big in two assignments again. And then after you calculate minutes, it's like 10 seconds, you're done. So it doesn't really work that well, right? Just combine it. Okay. Any question? Huh? 到時我會剔名，或者佢哋